The jaw setup in Mancandy is another case where I need action constraints, and bones to drive the shape, rather than using simple shape keys. Now the reason for this is also because the jaw is a rotational motion rather than a translational motion in general. First of all, let's look at how that's broken down into components and then constrained, and then we'll look at the deformation of the mouth. The fun thing about this is that it has to combine with the shape key driven actions of the mouth, for instance the smile and frown shown here, which is purely shape key drivers. Well, first of all, as we saw with the eyes, we have to break down this sort of up, down, left, right, and even in the case of the jaw, back and forward motion into a series of x-axis rotations that we can use to drive action constraints. And that's done with these little green bones, here, here, and here. If you look at this bone, it's got a lock track axis looking at the bot jaw, with the x-axis locked, tracking on the y, and so that allows us to track the front and back motion of the jaw on its x-axis. This guy is our top-down, is up-down bone, and you'll notice it's tracking as the jaw is opening and closing. And finally, this guy is our side-to-side bone, which tracks the x-axis motion of the jaw. And that's driven, and that motion is driving actions on these two bones in the jaw via action constraints, as we saw for the eyelids. So there's an action for there's one action for going up and down, which is driven by these two action constraints for going up and down, and that's the jaw track vert bone being used to drive the MC driven mouth open closed action, which is this action here. And then we have the jaw track horizontal going from 1 to 3 is driving the MC driven mouth left right action, which is this action right here, which is more visible from the front view. And this is what happens as you move that bone left and right. And finally, the jaw track back forward bone, that one at the top there, is driving MC driven mouth back forward action, which is here, which simply pushes these two bones back and forward. Now the reason I have two sets of bones for the jaw instead of one is so I can vary the rotations a little bit so that the jaw continues moving the same way as we open it, but as we close it, the bottom jaw continues to move up even while the lips are closed. So you can have Mancandy chewing a little bit, or compressing his lips a little bit further, compressing his jaw a little bit further with his mouth already closed. Now the last thing to point out is these chain of bones that weights the mouth, and it'll be more easy to see what they're doing in octahedron mode. And they're basically two little IK chains that are on either side of the mouth that have their root in the head part and their tail IK constrained to a child of this jaw, visible over here, and they're being used to deform the mouth. Now this is a setup that may not work in all situations for all meshes, but it happened to work very well for Mancandy, primarily due to his simple mouth. And that's it for the really complex setups on Mancandy's mouth. There is a simpler setup that we use for his tongue, If you look in wireframe mode, you can see that his tongue is this kind of flat shape that you can see here, and you can peer into his mouth to see it over there. And the tongue is simply set up by 3 bones as controls, and these bones simply stretch to one another. It's not quite obvious how this is working when you're manipulating them directly, and the shapes are working like that, but you can see that stretching the tongue causes it to get thinner. And if you turn off Draw Shapes for a moment, you'll see that's accomplished with a set of stretch 2 constraints, where each bone is just constrained to the other. And if I turn on the geometry bones, you'll see that there's one more for the base that we don't actually control as animators. And so that allows fairly easy positioning of the tongue, and it allows it to get thinner as it stretches out, or fatter if we compress one part towards another like that. And so you can get a very fluid shape for the tongue out of these 3 bones. They're not the most elegant way in the world to pose the tongue. However, it's actually a simple setup, and you really don't need to animate the tongue that precisely in 99% of situations, because the tongue will basically move at very high speed from one pose to another and then hold that pose, for instance when the character is talking and making phonemes. The motion of the tongue itself happens over a frame or 2 and is very hard to see to the naked eye. So that concludes most of the setups for the first layer of ManCandy's facial controls.